Lorenzo Massimo Polgar, Rijksuniversiteit Groningen, the Netherlands.
That's me. So, how did you all get here, physically? You probably arrived either on foot, by bike, or by car. And on the bottom of all of these, there's rubber. It's an irreplaceable component in products we use everywhere around us. But unfortunately, with all these just used rubber products, there's also huge amounts of rubber waste. Rubbers are dumped as landfill, burned for energy, or shredded into the asphalt when they're used, all placing a burden on the environment. But wouldn't it be great if we could make a new rubber tire from an old rubber tire? Instead, we keep adding unrecyclable waste to this pile. Researchers have been looking for solutions to this problem and indeed try to recycle these rubbers into new products. And to understand the problems they're having, we have to go back to the chemistry. When we obtain a rubber from, for example, a rubber tree, it comes out as a white viscous liquid that consists of individual polymers that are free to move around and can be shaped into any form. This form can be fixed by connecting them, fixing them in an elastic network, restraining their movement. That gives these rubber products the elastic properties that are characteristic for them. Unfortunately, these connections also make the rubber products unprocessable, like the liquid. They cannot be shaped into a new form. So how can we go back to a shape that is again processable? The answer is obvious, by simply cutting the red connections, right? Well, people have been trying doing that, and it's very hard to do so selectively. And you'll always cut some of the rubber itself, resulting in a degraded rubber that cannot be used for any product. So instead, I would like to use an alternative approach, which is based on a typically Dutch drawbridge that can open and close on command, with an external feature controlling whether it's open or closed. Now, a prime candidate for that would be temperature. And I'm really happy to tell you that in the lab, I was able to make a fully recyclable rubber product based on this very principle. This rubber, when heated up at temperatures at which rubbers are normally processed, can be shaped into a new form and flow, like the liquid, and in form like a bike tire. But when cooled down, the connections form, and the material gets the properties that you typically want your bike tire to have when you use it. And if we can do this over and over again, we have a fully recyclable rubber product, because this bike tire, when heated up, can simply be made into a new one. And with this new fully cradle-to-cradle recyclable rubber product, these mountains of rubber waste are a thing of the past.